derivative of y equals x to the power of n from first principle. Y equals x to the power of n, that's the first point on the curve, and then we find the second point on the curve by saying that y plus delta y must be equal to x plus delta x to the power of n. That's the second point on the curve. I can then say delta y equals, so I move the y to the other side, x plus delta x to the power of n minus y. But y is x to the power of n, so delta y equals x plus delta x minus x to the power of n. Now that's n here, by the way. Now I need to expand this, so I'm going to use binomial expansion here. Talking about binomial expansion, a plus b to the power of n is a to the power of n plus n a to the power of n minus 1 plus n into bracket n minus 1 a to the power of n minus 2 over 2 factorial. This is over 1, that's b1, and that's b squared. That's b to the power of 1. That's b to the power of 0. So this is to the power 1 factorial, and this is to the power 0 factorial. So actually this is n minus 0, b to the power of 0. b to the power of 0 is 1. Anything to the power of 0 is 1. 0 factorial is 1. 1 factorial is 1. This is b to the power of 1, a to the power of n minus 1. You can imagine what the third one would be. So I have to take this n to the power minus 2 down here. Then that would be n a to the power of n minus 3, b cubed over 3 factorial. So that will be the next one along. So that's how it goes when you do that expansion. And to simplify this, it will be just a to the power of n plus n a to the power of n minus 1 b plus n into bracket n minus 1 a to the power of n minus 2 b squared over 2. Don't forget this is over 1 and that's over 1. And so that continues. But we don't need the rest of those. We just need actually the first two. So that's a plus b to the power of n. Now for my expansion, I'm going to replace a with x. So that's x here. This is x. So, and the b is delta x. So writing that expansion, I can then say delta y equals, so I'm going to put this as x, and that's delta x. So it's going to be x to the power of n, because a is x and b is delta x, plus n x n to the power minus 1 delta x plus n into bracket n minus 1 x n to the power minus 2 delta x squared over 2, and it goes on, then minus y, and the y is x to the power of n. So delta y equals x to the power of n plus n x n to the power minus 1 delta x plus n into bracket n to the power n minus 1 x to the power n minus 2 delta x squared minus x to the power of n, which is actually what I've written there. So you can see that x to the power of n plus x to the power of n minus x to the power of n cancel out, and the delta y will be equal to n x to the power of n minus 1 delta x plus n into bracket n minus 1 x n to the power x to the power n minus 2 delta x squared over 2, and then, oh, that's over 2, and that goes on. Now, I need to divide both sides by delta x. So if I divide that by delta x, I have to divide this by delta x and divide that by delta x. As you can see, delta x cancels, and that cancels that. You got 1 there. So you're left with, and the rest goes on as well. And so you then get delta x, delta y over delta x equals n x n to power minus 1 plus n into bracket n minus 1 x to power n minus 2 just delta x plus, well, that's plus and plus there, dot dot dot, and it goes on. So to simplify this, we have to do in the limit. So I'm going to do in the limit now. So continue from here, we now have in the limit where delta x tend to 0, delta y over delta x would tend to dy over dx. That's what in the limit says. That means we bring the difference close together, and that difference, delta x, gets so small, and therefore we can then use dy dx. That's when we have the authority to use dy dx. Then we can say dy dx will be equal to n x to power n minus 1 plus n into bracket n minus 1 x to power n minus 2 times delta x over 2. But delta x is 0, and that goes on. Delta x is 0 here, so that would be times 0. And therefore, we get, if that's 0, the whole thing is 0. Therefore, we get n x to power n minus 1. And that is dy over dx. So that's the derivative of y equals x to power of n. So whenever we see a function where y equals a polynomial function, that's a polynomial function, where x to power of n, and we need to derive that, we need to find the derivative of that. So that's f dash x will be n x n to power minus 1. Or if you have y equals a x to the power of n, the derivative f dash x will be a n x to the power n minus 1. So what you do is you bring the n down and you subtract 1 from there. That's the formula for deriving and for differentiating a function of x, or a function of t, or a function of v, or a function of r, or any function with respect to another variable. So that's the derivative of differentiating one variable with respect to another variable. So you could use this as v equals a r to power of n, and the derivative will be f dash r, which equals to a n r to power of n minus 1. That's another example of how to write it. So it's, remember, y and x are just default. They're arbitrary. So you could use any other variables here. You could use time, you could use area, this is volume and radius. So you could use anything as well, or velocity and time graph, anything.